All right, let's just dive right into what sounds like an absolutely impossible reality. Picture this. You leave your house for work on a typical Monday morning, and you drive past a completely empty, flat gravel lot, nothing but dirt, right? You go about your day, you go to sleep, you wake up, and by Tuesday evening as you drive home along that exact same route, boom, there is a fully finished, towering apartment building standing right there on that very same spot. I know, it sounds totally like science fiction, like something out of a futuristic movie. But what we're about to explore in this explainer is not fiction at all. It is the very real, rapidly approaching, and honestly massively disruptive future of construction.
28 hours and 45 minutes. I really want you to take a second and just let that time frame sink in. That is a total smash cut to reality. In that exact, unbelievably tight window, a fully finished 10-story residential apartment building was completely erected. And we're talking about everything here: the walls, the glass windows, the exterior balconies, the internal electrical wiring, the plumbing, the whole shebang. Before the sun set for the second time, a patch of dirt literally became a 10-story residential complex. It completely defies almost everything we think we know about how the physical world gets built.
Now, to truly wrap our heads around the sheer scale of the disruption we're talking about here, we have to look at the standard benchmark we've all just kind of accepted. Your typical 10-story building, using the traditional methods we see in pretty much every city around the world, takes well over a year to construct. We're talking roughly 16 long months, on average, of noise, traffic delays, and heavy machinery. So contrast that sluggish, grinding traditional build time with Broad Group's 28 hours. The difference is so vast, it almost breaks your brain. Either something is very wrong with these numbers, or something has fundamentally changed about the mechanics of how buildings actually get made. A change so profound, it completely shatters our preconceived notions of construction.
Section 1, the factory-built revolution. To really understand how we leaped from 16 months down to 28 hours, we need to look at the origin story behind this anomaly and the specific company that actually made this impossible leap a reality.
So the mastermind behind this massive breakthrough is a genuinely fascinating guy named Zhang Yui. And honestly, the most surprising detail here, he wasn't an architect. He wasn't a structural engineer. Actually, he wasn't even from the commercial construction industry at all. He was an air conditioning tycoon, the wildly successful chairman of Broad Group, making his absolute fortune in industrial cooling systems. But everything changed for him, and his entire life trajectory shifted right after the devastating 8.0 magnitude Sichuan earthquake in 2008. It was a tragedy of just immense scale, where tens of thousands of conventional buildings simply collapsed under the stress. And this really brings us to the emotional core of this entire technological breakthrough. You see, Zhang Yui looked at the sheer devastation in the aftermath of that earthquake. He saw that rigid, heavy concrete was directly responsible for so much of the destruction and the tragic loss of life. And he just asked one incredibly powerful, paradigm-shifting question: why are we still building this way? He realized that when the earth moves, concrete doesn't flex, it doesn't bend, it simply snaps. And in that exact moment of clarity, he decided to pivot the massive resources of his entire manufacturing empire to fix a broken global industry. The absolutely crucial point to grasp here is how his completely reimagined system actually works. Broad Group uses this really ingenious flat pack methodology. Think of it almost like life-sized IKEA furniture, but, engineered to absolute structural perfection. Here's how it goes. Step 1. Modules the size of massive shipping containers are built entirely indoors under pristine factory conditions. They're completely pre-wired and fully fitted with plumbing before they ever even see the outside world. Step 2. Trucks transport these finished blocks right to the site. Step 3. Cranes simply lift them into place. And Step 4. Giant steel bolts lock them all together. That's it. There's no pouring wet concrete. There's no waiting weeks for materials to cure. There's no stopping construction just because of rain or bad weather. It is pure, uninterrupted assembly. Now, to prove that this concept could actually scale up to city sizes, Broad Group went massive. They launched a project called Mini Sky City, and the statistics from this build are nothing short of monumental. Get this, a 57-story skyscraper was erected from the ground up in just 19 days, utilizing a workforce of roughly 1,200 workers. By strictly snapping together these factory-made parts, they entirely bypass the massive, sprawling delays you get when dealing with wet concrete. And in doing so, they eliminated an estimated 15,000 concrete truck deliveries from the local roads. 15,000! So it wasn't just a construction success, it was an absolute masterclass in urban logistics. But hearing all this, you're probably wondering the exact same thing pretty much everyone else does. is it actually safe? Right? Like, can a building snap together in a day really protect the people inside it? Well, let's address those concerns head on. Traditional concrete structures have an expected lifespan of about 50 to 100 years. And as we discussed, they are notoriously rigid. In sharp contrast, broad group steel modules are designed for a 1,000-year lifespan. They are 10 times lighter, they are 100 times stronger under load, and crucially, they have been independently verified to withstand a staggering magnitude 9 earthquake. Plus, because the entire structure is essentially bolted together, you can completely unbolt, dismantle, and recycle the entire building at the end of its life. How cool is that?
Moving on to Section 2, the 3D printed alternative. Because Broad Group isn't the only major player in this rapidly evolving game. There is actually a parallel, equally disruptive technology tackling these exact same construction bottlenecks, but from a totally different angle. Meet Windenson. They're an incredibly ambitious company operating out of Shanghai. Now, instead of stacking pre-made factory-built rooms like giant building blocks, they're literally printing structures, wall by continuous wall, right there on the ground. Using this highly automated technology, they employ giant robotic industrial nozzles to meticulously layer a specialized mixture of recycled construction waste and fast-setting cement. It is literally industrial-scale 3D printing in action. They're taking a technology we usually associate with, making small plastic trinkets on a desk and scaling it all the way up to manufacture human habitats.
And the speed of this automated layering process? It's just absolutely staggering. 10. In a single, uninterrupted 24-hour run, Windenson produced 10 complete, structurally sound, and entirely livable houses. 10 homes in one single day. And they managed to do this while drastically cutting down on material waste, too. They dropped the environmental footprint by between 30 and 60% when you compare it to a traditional, messy construction build.
So we really have two brilliantly distinct innovations running in parallel here. You've got Broad Group's off-site modular stocking on one side, and Windenson's on-site automated printing on the other. Now, the specific mechanics and the engineering differ completely from one another, but the underlying logic, the real philosophy driving both of these massive companies is exactly the same. Pull construction out of unpredictable, slow, open-air environments, eliminate massive amounts of grueling manual labor, and entirely eradicate time waste from the equation.
Which brings us to Section 3, a $1 trillion market. Who is actually buying into this? We really need to shift our focus to the massive financial realities and the surging global demand that's driving these rapid construction technologies forward today. Because the financial projections here prove, beyond a shadow of a doubt, that this is no longer just some fringe experimental concept. Not at all. This is a massive, rising tide poised to completely reshape the global economy. The global modular construction market hit roughly $95 billion in 2025, and projections have it zooming past $175 billion by the year 2034. That is an absolutely explosive growth trajectory for an industry that has essentially remained stagnant for the last century. And we're seeing heavy-hitting institutional money, along with aggressive government policies, actively backing this shift worldwide. This is a true global phenomenon. China alone has committed over $1 trillion to infrastructure, leaning heavily into these faster modular methods. In Southeast Asia, Singapore has actually gone as far as to legally mandate modular methods for certain public housing projects, just to ensure absolute efficiency. And over in Europe, the UK has confidently pumped billions into off-site construction investments. So the smart money and the political will, they are absolutely there. But why the sudden global rush? Well, it really all comes down to a staggering, heartbreaking deficit. 100 million. That is the estimated global housing shortage right now, today. And that number is only climbing as populations grow and urbanize. Add in the compounding facts that raw construction costs are rising relentlessly across the globe, and the skilled construction labor pool is rapidly shrinking. The average construction worker in the US, for example, is over 40 years old, and younger generations simply aren't entering the trades fast enough to replace them. We urgently, desperately need faster, less labor-intensive solutions just to keep a roof over the world's head. And that leads us to Section 4, why isn't this everywhere? It's a massive, slightly frustrating reality check. If this technology is so vastly superior, so efficient, and so desperately needed, we have to uncover the systemic bottlenecks that are preventing these totally obvious solutions from solving our global housing crisis overnight. The truth is, the bureaucratic reality is massive, and it is deeply entrenched. The roadblocks standing in the way of progress aren't really technological, they're institutional. Most global building codes are stubbornly, historically outdated.
They were written exclusively for pouring concrete and framing timber, so they completely ignore the existence of factory-assembled steel modules. On top of that bureaucratic red tape, there's strong organized union pushback out of fear of job losses, and legacy mega-developers already have their massive supply chains firmly locked in. Disruption at this unprecedented scale threatens massive, century-old established industries, and believe me, those industries are fighting back.
The real-world cost of these locked-in legacy systems is staggering when you finally put them side by side. On the exact same planet, in the exact same decade, armed with the exact same raw materials, China can throw up a 26-story residential tower in just 5 days. Meanwhile, trying to navigate a basic mid-rise apartment building through the endless red tape, the zoning meetings, and the legacy construction processes in a city like London or New York, that takes upwards of 3 full years. We are practically living in 2 completely different centuries when it comes to human development. The future of how we live, faster, stronger, infinitely more sustainable, and just far more efficient is already standing. It's already fully occupied, and it is already scaling up globally. The only real question left to answer is how long it's going to take for the red tape to clear so that this future can arrive in your own neighborhood. So, as we wrap up this explainer, I want to leave you with one final thought to really ponder. Would you live in a building that went up in a single day?